So I found myself looking to buy an Amiga chipset. Now, where's the best place to find one of those? Well, inside an Amiga. It was the ECS chipset that I was after, and in particular one with an Agnes 8375, so that I can have 2 megabytes of chip RAM. Now, I need all of that for an upcoming project, and rather than buy and gut a perfectly good Amiga 500 Plus, instead I bought this motherboard. As you can see, it does have all of its custom chips, but it has suffered quite a bit of battery damage. So this is the perfect contender to strip for parts. Now, the other thing you might notice is that someone has had a go trying to repair this in the past. Some of the corrosion has been cleaned off. You can see some exposed copper there. But the guy I got this board from says he couldn't get it working. He just let it go for spares. Spares is all I need, and yeah, I'm just going to strip it. No need to fix it. I'm definitely not going to fix it. Nope. Let's fix it. So this board will be getting stripped of parts for my other project. This is really just one of those because why not things. I just want to see if I can fix it. Now, as I said, the guy I got this from has had a go. He's exposed some of the copper, and he's obviously found a couple of broken traces. I can see a patch wire at this point here, and if you turn to the underside, well, you can see a significant patch wire has been put here. He's also had that socket off, which is Gary. So I think what we're going to do in the first instance, rather than risk trying to power this up and cause any damage to any of these custom chips, which I am trying to save. Well, I say that. I know the guy who did have this before me had tried to power it up on several occasions. But look, I don't want to risk doing any more damage. So I think the first thing we should do is remove all the components within the affected area. Certainly want to remove all the ICs anyway. So everything in this sort of area here. In fact, we'll pull all of the custom chips, just get them out of their sockets, just in case there's any corrosion hiding within those sockets that would need to be addressed. But we'll remove the socket for Gary, and we'll remove these as well. The corrosion gets down onto the pins of this 74F373, so we'll pull that out. The actual RAM chips themselves though, well, they look okay. So hopefully these come out okay. I mean, they've been out recently. That's actually one socket that size and then another bit of a socket cut down. Nothing wrong with doing that, but we're going to replace it anyway. Socket underneath Paula looks okay, to be honest. As does the one for the even CIA. What about the odd? Oops. Yeah, that looks alright. I can see already though that the socket underneath the knees here looks kind of crusty. Wow, yeah, that socket is gone. And there is a fair bit of corrosion on the legs of the knees. I bent one of those pins there a bit. It's better. So we'll give that a going over with the fiberglass pen, but that socket will have to be replaced. What about under the CPU? I would rather not have to replace this socket because I don't really have any spares for it. Which is a complete lie. I do have one spare socket for a 68K CPU, but I need that for said upcoming project. And yeah, luckily enough, that socket seems okay. We'll get the ROM out. That one seems okay. Now, getting this fat lady out of bed, removing Agnes from this socket, well, that is going to be fun because I still don't have a new PLCC extractor. It's one of those things I keep meaning to buy one and then just keep forgetting about it. I used to have one, although I fell out with it, and it might have found its way into the bin after it took a chunk out of an Agnes on another A500 board on me. It was one of those cheap ones off eBay, and every time you used it, it just slipped, and it took a bit out of the corner of the chip and put a nasty scratch on it. The chip still works okay, but in this instance, I want to try and get this out without any damage. So what I'm going to try and do is use my tweezers. And my thinking is, given the shape of these, that if I stick one leg of it down in there and try and pry it up, just one bit at a time, you know, the chip might come out. Or it might just bend my tweezers. Oh, that was not a good idea, was it? Right, here's what I'm going to do. I'm going to spray a lot of contact cleaner on that to try and persuade this socket to let go. So I've sprayed some on there. I'm just going to try and work it into it a wee bit with a toothbrush. And then I will risk my tweezers one more time. Come on. Out you come. Nope, that is not happening. Need to think of something else or I'm going to wreck these. So about the only other thing that I can think of doing is wedging a screwdriver down in either side and forcing the chip out. But that will, without doubt, smash the socket, if not damage the chip. So I think what I'll do is we'll just let Agnes have a lie in. We'll leave her in bed for now. And I'll just order myself a new PLCC chip extractor. But while we're waiting for that to come, let's get all of this stuff removed. Everything with a Sharpie mark beside it, that's what needs to come out. That's all the chips from the other side that we are going to remove. So no time like the present. I've got an awful lot of desoldering to do. Well, that took forever, but it's all off. Just really a matter now of starting the cleanup. Took the knees off as well, or took the socket for it off anyway. That's all our components waiting there to go back on. Although quite a few of the passives were physically damaged. The legs had snapped off a couple of the resistors and the capacitors. So where I have replacements for these, I'll just do that. And it's funny how the corrosion got to the Denise socket. You can see a bit of it on the board there. The actual socket itself is in terrible condition, so that will just be replaced. But nothing else up this end of the board has any corrosion on it whatsoever. Just Denise. So we have an awful lot of cleaning up to do. This is really just going to be a mixture of the fiberglass and steel wire pens. Some of it though is so heavily corroded, the likes of this area here. And I think I might have to resort to the screwdriver to scratch some of that off. So it's going to take a while to do all of this as well. Let's just get it done. Did you ever start something and then ask yourself, why? Between the desoldering and the rubbing this down, I am currently into it for coming up to 4 hours. But it has to be done if we're going to try and fix it. I dare say I've got another hour's work here left at least, so I'll just get on with it. Well, I think that's about as good as I can get it. You can still see lots of little black bits in the exposed copper there. Lots of pitting in it from the corrosion, but I think it just is what it is. Given how heavily corroded it was, I don't think it came up that badly. There are 2 bits of damage though, just here and here. The board has delaminated. Now, I don't know if that's something I did, or if those are from the previous repair attempt, but you can see that the top surface of the board has come away and it almost feels a bit spongy. Now everything across it still makes continuity okay. But it's just something to bear in mind. If you're working on one of these, go carefully with the heat. And the next job, and the reason that I have the multimeter out, is to start looking for breaks. As I said, there was one repair carried out here before, and there was that big jumper wire on the back, but I have removed that, and as you can see, once it's cleaned up, there was really no need for that. The copper underneath isn't broken. But I'm just going to spend some time, go around this and see if I can find anything broken. Then we'll fix that, stick it all back together, and you never know, it might just work. Well, I found one. This via here, that has a trace coming down this way and it should be connected there, but it's not. Now because all that copper is exposed, we can go to there and hear that that is connected. It's not on the via itself, so there must be a split there. And in fact, you can just about see that the copper has come away from the hole beside it. What about going up the way? And yeah, it is split there as well. So we need to patch that. I'm just going to put a big circle around it for now. That Sharpie just washes off with the IPA, and I'm going to have a look for anything else. So yeah, there are a few repairs required. Now two of these, this one here and this point here, these run on to two jumper positions, JP7A and JP9. And just taking a look at my other A500 Plus motherboard, well, those two jumper positions are open anyway, so strictly wouldn't be necessary to repair those points. The other ones though, those definitely do need fixed, so let's do that. So I'll just do one of these on camera. We'll pick probably the easiest one to do on camera. Let's do this one here. So let's just clean off our bit of marker. And we'll just double check that that is definitely broken. Yep. Continuity. No continuity. So I'm just going to put a little bit of flux down. Then with soldering iron, let's try and tin up the area. Okay. Now to help orientate the wire, what I'm going to do is use a bit of my favourite blue tack. That'll just hold the wire down for us, and then I'll try and tack it into position. So a bit more solder on the iron. That's that down. Now my original plan here was to thread this wire down through the hole, but in doing what I have so far, I have blocked the hole. So I think all we'll do is just cut this off. We don't actually need that hole at this position. You know, there's no component to go through it. Push our wire down into it there a bit, and just drop a bit of solder on top. Then if I just bring in the meter again, let's just check this. So that's one down. I'll do these other ones. There's a bit of solder on that large copper trace there. That's the problem with having all the copper exposed, but it's left a bit of a blob there, so I'll tidy that up. Then I'll do these other ones, and we'll have a think then about what's next. Okay, all the little patch wires are installed as we need them. And you might notice now that some of the copper has gone silver. That's because as I've been working along here, I've just been tinning it up. And the process for doing that is really nothing more than putting a bit of solder on the iron, getting the wick, and just dragging it over the top of the exposed copper. So I'm just going to do that to coat all of the exposed copper areas. Well, most of it anyway. I think I'll just do the traces that are exposed up and around here. I don't think I'm going to get too worried about the big ground planes. But then again, I suppose if we're doing it right, I may as well just do it. Well, I tinned up all of this area, but didn't bother with this bit down the bottom. Well, I say that, I did turn up just at that position where the chip has been removed, and there was a bit of cleaning up done there. But this large ground plane at the bottom, I didn't bother with that. Instead, all I done there was give it a coat of the clear nail polish. And in fact, once we get all the components back on here, I think what I'll do is go over any of the traces that you can still see with this clear nail polish, and that'll just seal them. If you ever needed to get it off again, it's simple enough. This stuff just wipes away with the acetone. Next job though, I think, is to start cleaning the ICs. There's one there, that's for position U10. The legs are a bit bent, but I'll straighten them. But more importantly, you can see the legs are quite green. And so to clean this and all the other chips, just a matter of getting the fiberglass pen again and rubbing it down. Doesn't take a lot, but you do need to be careful, because if you apply too much pressure, you're going to start bending these pins, and the more you bend them back and forward, the more chance there is that they'll snap off. All cleaned, and I did the knees as well. So just one last thing I want to do before we reassemble. Most of this is all 7/4 logic, so we can test all of that on the computer using our TL866 U10 here. That is 74LS244N. Then on the computer, we just want to select our chip, logic IC 74244, and test. So potential error, just let me try and straighten the legs of it a wee bit, just to be sure that we're getting good contact. Try that one more time. Yeah, it was just a bad contact. It's now testing fine. So I can go through all of these, test them. Well, apart from that one is a clock chip, but all the rest of them I can test. And if they all pass okay, the only thing left to do is reassemble. Well, we've got a problem. This chip here, 74LS373, that came out of position U13, which was here. So not a million miles away from the battery, but that chip is bad. All the rest of them test okay. I do have a replacement 373 though. That's a brand new chip, so yep, that tests okay. We can put that one in to replace that. I was just having a look for sockets as well, and I don't actually have sockets suitable for Gary or Denise. So what I'm going to do instead is just use pin strips. I have these things here, although the legs on these are way too long. I bought these for the other Gotta Go Fast RAM expansion for the A500. You know, it adds 8 meg of fast RAM. But to be honest with you, they weren't really a good buy, just because the legs are so long. But they're perfect for something like this. I can stick them down into the hole, cut the legs to size, and they'll do rightly. Time to do some soldering. Well, all back together. And do you remember that point where I patched initially on the video? I said there was no component to go there. Yes, there was. A capacitor. I just replaced it with a new one though. And speaking of new capacitors, I had to replace the ceramics that were in this location here, just because they were damaged. But I didn't have any of the same type, you know, in this sort of package. I just have these ceramic discs, but same difference. They'll do the same job. Next thing really is just test it. Let's see what it does. So get all these chips back in. Just looking at the legs of the knees here, because I went over them with the fiberglass pen, I've actually exposed copper on those, and that will oxidize and probably cause problems at some point in the future. So if this chip does work, what I think we'll do is just go over it with a bit of solder on the iron, just to tin up those legs again. Power and video are ready to go, but I hooked up a keyboard as well. Let's pull this out of my other 500 plus actually. And just so we can see the power LED, as if there are any faults, a power LED might flash and give us a hint as to what the problem may be. Here we go. What a pretty picture of green. So yeah, we've got a problem. And we do indeed have an error code flashing here. So let's just wait for the reset again. Then we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 quick flashes followed by one longer flash. Well, if we look up here on the Lemon Amiga website, there's a nice list of error codes. Green screen followed by that flashing. Well, that's pointing to a bad Agnes. But let's not get too ahead of ourselves. I think the next thing I want to do, considering I just took my other A500 Plus apart to get the keyboard from it, let's swap all of these custom chips into that machine. We can do them one at a time, and just to prove if these are good or if indeed there is a problem. Hopefully not a problem with Agnes though. Out of all of these chips, this is the main one that I wanted to get from this board. Okay, first thing we'll do is just test the CPU, because this is my Pi Storm A500. I just want to get that Pi Storm out of the way. This socket is actually quite loose now because it's had those round pins in it, but hopefully that will make okay contact just for testing. Now we're not testing this much beyond just powering it up to see what it does. I just want to make sure that none of those custom chips are the cause of the green screen on the other board. So yep, system posts okay with that CPU. What we'll do next, just the ROM right beside it, and equally, yeah, that seems fine. Yep, that's grand. What about Paula? Well, no problems there. Gary. And again, it certainly seems as if it's booting okay. And yeah. The two CIAs, let's just do the both of them together. Yep, nothing there causing any problems. Denise. And again, that chip seems good. I really hope this problem isn't being caused by Agnes. But there's only one way to find out, isn't there? And it's fine. So our green screen error on the other board, at least we now know it's nothing to do with its original chipset, because that's it all in there and it's seemingly working without problems. Well, at least we know the problem is not in one of those custom chips, and it's highly unlikely that simply pulling them all out and putting them all back in would fix it, but you never know. Still a lovely shade of green, isn't it? So here's the question, will it be one of these, one of the RAM chips, or have I missed something? I suppose the next thing we should do is write a copy of Diagrom. So Diagrom, the Amiga diagnostic ROM, is available from this website. I'll leave a link to it in the video's description. You can download the ROM images here, already byte swapped, although you'll need something to program it, and of course you'll need a 27C400 ROM chip. And here's our chip programmed up, so let's drop it in there and see if this tells us anything different. So flashing green red, it does eventually give up on that and tries to continue booting to the Diagrom menu, but as you can see, other than some colourful lines, we don't have a lot to go on. You can get more information from Diagrom using the serial port, and rather than hook up that serial port to some terminal emulator on my PC, let's rather connect it to the real thing. This terminal came my way as part of the big motherload pickup from way last year, and I knew I was holding on to it for a good reason. This definitely sounds like the perfect opportunity to try it out. Now, to get Diagrom to talk to this, we need to go into the setup and just check the communication settings. So baud rate 9600, data stop bits 8/1, parity none, and all the handshaking off. That is what we need. And if I just power on the Amiga, hopefully we start to see text scrolling here, and it'll give us some idea of what's going wrong. It's scrolling quickly. How do I move through this or stop it? Break. Okay, I can pause the scroll just by pressing break. But let me reset here. And apologies for the flashing Amiga monitor in the background, but I can only sync the camera to one of these, and I thought it better to sync it to the terminal. So let's power on again. And if I just pause it at that point there. So I think we've missed the first couple of lines, but reading what we have here anyway, CPU seems somewhat alive. Testing ROM address access OK. Now ignore this, the likes of that 32M or 0M. Those are terminal commands that would be trying to tell this thing to change the color of the text. But obviously with this just being monochrome, well, it's ignoring those and just sticking those commands onto the screen instead. So everything looks okay until we get down to here. So test of writing word AAAA to 400 failed. Writing the word 00AA, that was okay. Writing AA00, that failed. Writing 0000, that was okay. Now that is part of the UDS and LDS line. What does that mean? Well, UDS and LDS, that is upper data strobe and lower data strobe, driven by the CPU via Gary. We have a problem with the upper data strobe, although the trace between there and there, despite the fact that it runs down here right beside the battery, well, the trace is fine. When I seen that on the schematic, that coming down here, I thought, oh, that must be the problem. Nope, it's not that, it's fine. So you might see that I have removed a couple of chips again, and I'm actually just in the process of removing these 4 again, and what we're going to do is fit sockets. I know I tested these in the TL866, and well, those 3 passed, that one failed, but we replaced it. But I'm starting to wonder, is there maybe a problem in these? Now, having a chat with a few guys online regarding that UDS problem, well, they suggested to test data lines 8 through 15 on both the processor bus, which is D8 through 15, and on the RAM bus, which is DRD 8 through 15. I checked them all 16 of them from 0 to 15, and continuity was fine on all of it. So new sockets and new logic chips. Well, apart from that one, that's the one we were already using as new, but I've replaced the other 373 and the 274 LS244s. These 2 are new as well. I don't have one of those, a 74139, so just reusing the original chip. And as I said, the error points towards those data lines D8 through 15. Those run through these 2 chips here. And if it's not the traces, if it's not the chipset, then it can only really be these, or I suppose it could be the RAM. But this is where all the damage was. And despite the fact that the original chips did test okay, well, 3 of them did, I just wonder how reliable is that test on the TL866. One way to find out, let's take it over to the bench behind me and see what happens. Okay, terminal is on, monitor's on, Amiga motherboard is hooked up. Let's throw some power at it and see what happens. It seems to have passed its test this time, and it looks like it's working. I do not believe this. Yeah, it looks like it's working fine. Diagram menu. Unbelievable. Absolutely unbelievable. Which one of these original chips do you think is the problem? All of them? One of them? Who knows? In fact, you know what? 74244N. Remember the first chip that we tested? It gave an error the very first time that we tested it, and I put that down to a connectivity problem. I wonder, is that chip actually bad? Well, I think it's that one. I'm not sure. There's 3 of them. But let's put it into that position there. And let's see if our green screen comes back. Nope, seems to be working okay. Just let me test the other ones as well. Maybe the process of me fitting the sockets, maybe that in itself has fixed something. Maybe there was a bad solder joint from when I fitted the chips into the board originally. Nope, there is the feedback. There's our problem. It must be that chip. Let's put the new one back in. And it's working again. Unbelievable. Another board that has sent me round in circles when in fact the problem was staring me in the face all along. One bad bit of logic. Just let me test this again on that TL866. So 74244. Test. And now it's saying it is bad. That test definitely came back good before. So it must have just been the case that this bit of logic here, it must have just been on its last legs. And between me removing it, testing okay, and then sticking it back onto the board, that must have been enough just to kill it. And this has been our problem all along. Let's put the original kickstart back in. I don't need this anymore. And away it goes. I cannot believe that. Stupid chip! Well, one Amiga 500 Plus motherboard fixed. I did run it through all the tests in Diagrom and the Amiga test kit. It passes everything, no issues whatsoever. So I didn't really see the point in boring you with all that. The board is working fine. In fact, the Shadow of the Beast footage that you can see on here running now, that was recorded from this board. There are no issues with it whatsoever. The problem in the end was that bit of dodgy logic. So perhaps that shows that you maybe can't fully trust that TL866 test, because initially it did show that 74LS244 as good. Now granted, the chip has eventually failed, so whether it was just intermittent or it was just on its last legs, who knows. But look, it's fixed now, and the only thing really left to do with it is scrap it, because I am going to recover the chipset. I do need it for another upcoming project. Now you may think it's a bit of a shame to scrap this board after spending a good week working on it, but hopefully when you see said upcoming project, you'll agree with me that it's worth it. And when I say I'm going to scrap it, I'm going to hang on to the board. You never know, maybe one point in the future I'll be able to populate it again. Or if we ever get another A500 Plus, well, I could maybe even use this as a test point. So yes, it's fixed. Ultimately, it's going to be recycled. What was the point? Well, I just wanted to see if I could do it, and we did get there eventually. So that is it for this video. Hopefully you enjoyed what you've seen, and if you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.